Hey guys, in this video I would like to show you how to create a function block in CODESYS, an interface for this function block, and a template in the visualization of CODESYS. Of course, I'm going to do this in two videos. In the first video I'm just going to show you the backend. So for the function block I've decided to create a very simple one. This will be a random number generator. So first of all, we need to create our POU. This will be a function block in structured text. We're gonna need an execute input, which is from type bool. We're gonna need a minimum. We're gonna need a maximum. So that's everything we need as an input, and as output we're gonna have a done bit, which is from type bool, and of course we're gonna have our random number, which is from type the int, double integer. My prefix is wrong. So now I'm going to need some local variables. First of all, I want to receive a random number with a rising edge. In this case, I'm going to need a rising edge trigger or one shot. So I'm going to name it execute. This is I'm gonna need a status for my switch case, which is from that integer. I'm gonna need a buffer for my result, which is from type the int. I'm gonna need a divider, which is from type the int as well. So first of all, I want one shot. So let's say the comment, one shot. The input will be our trigger. So every time we have a rising edge here, so falling and rising edge, we're gonna receive on the output of this function block a true for one cycle. So you need a rising edge. So let's go to function block, and we are gonna say if there is a rising edge, then we want to set our status to 0, because this will be our initial case. Let's make our state machine. So case will be our status 0, 0, and 10,000. You can do it out without a state machine. You can do everything in one cycle, but I want to receive a rising edge on my done bit. That's why I'm going to do it in a state machine. So here I'm gonna check the same thing basically. So if we have a rising edge, then I would like to set the output to false. For one cycle will be this, and yeah, we can set our random number to 0 as well. Doesn't really matter. And then I want to create my divider, so I'm gonna do some calculation. My divider will be the divider is equal maximum minus minimum. So this will be the divider for our random number. So to get the random number, we're gonna need one function from CODESYS, from the CODESYS libraries. So you have to add the SysTime library. SysTime library. So after we add the SysTime library, you can see the SysTime library has three functions: SysTimeGet in milliseconds, SysTimeGet in nanoseconds, and SysTimeGet in microseconds. For my case, I'm just going to use the SysTimeGet in milliseconds because that's quite enough. So here, what we want to do is gonna create the result will be equal to, let's say, SysTimeGet in milliseconds. This type should be converted to double integer, and this will be modulo our divider plus 1. You may ask yourself, why plus 1? It's pretty simple, because let's say we have here this parameter is 2. Our minimum is 0 and our maximum is 2. So let's say 2 divided 2 is 0. 3 divided 2 is 1. 4 divided 2 is 0. So we're never gonna receive the maximum. That's why we just make a plus 1, so we can receive the numbers from 0 to 2. That's the basic explanation. And after we have our result, I'm just gonna set my status to 10,000. And in the 10,000, I'm just gonna say, let's say done is equal true, and here the result is equal to the buffer result, and that's basically the random number generation generator. So I forgot to change the name of my POU. I'm going to do that right now. Let's call it a rand generator. It's not in use. And one more thing, after we receive our result, we should set the result plus the minimum to be between those two, to be between the maximum and minimum. So plus the minimum. So that's basically the function block. Let's declare it and give it a try. Run is from time fp a random generator. Now I'm just gonna code a function block without the in and outputs because I want to create a structure as an interface for this function block, which will be connected with the visualization afterwards. So now I'm just gonna show you the functionality, and afterwards I'm gonna create the structure for the interface. So as you can see, our minimum is 0, our maximum is 0 as well. Let's put 2 to it and just generate some random numbers. We receive 1, 1 again, 0, 0, 1, 2. So the function block just generates random numbers. Let's change the values. Let's make 50 and let's say 100, and generate some random numbers. We receive as an output 96, 99, 52, 76, 63, 83, 91, 88, 86, 62, and so on. So every time we have a rising edge on the input, we receive a different random number. as you can see this, and it's going to be in between the minimum and the maximum as well. So we can receive 50 and we can receive 100. As promised, let's create the interface for our random number generator, or for this class. This will be a simple structure. So TUT, and this is, I'm gonna go st random generator as well, and this will be a structure. So in the structure, I like to have under structures, so nesting. This is called nesting. So I would like to have my inputs and outputs separately. So I'm gonna create 2 more structures. Let's say st in gen, and a new structure which will be st out gen. Now I'm just gonna copy my inputs. You don't need to do that. You can have them in one structure if you like, but I think this is a cleaner solution, so I'm doing it always. And of course, now the outputs, I'm gonna get to the out structure, and this, both of them will be declared in here. So I'm gonna have, let's say in, it's gonna be from type st in generator, and the out, it's gonna be from type st out generator. So here I have error. Now of course this is now the this is the structure that is my interface. So let's declare this structure as an interface. I'm just gonna call it itf gen rand. So this is from type st rand gen, and now I'm just gonna call the function block again, and just gonna map everything like this. So how to do it? We're gonna use the dot in, then execute, and again for the inputs, minimum, maximum, and here we're gonna use the output structure, the done bit, and of course we're gonna have the random number bit. So let's start our program again and write some numbers. Let's say, I don't know, 20 and 30. Let's start our program and just generate some random numbers. 24, and so on and so on. So in the next video, I'm going to use this structure as an interface to create a template in the visualization. For now, thank you for watching and have a good one.